So this is a question that students often ask. What calculus do I do here? Should I take a derivative? Should I use an integral somehow? That's a difficult question to answer. Let's look at a particular problem and see if we can figure out what calculus is necessary for each of these different parts. In this problem, we're given a graph which represents the rate in calories per minute at which a person is using an exercise burns calories. A portion of the graph is given by this equation, that's this portion here, for the domain from 0 to 4, and the rest of it is a piecewise linear function. So you need to remember that f is already a rate, and notice that we have rate type of units here. The first thing we're asked to do is find f prime of 22. They obviously want us to take a derivative. So I need to remember that a derivative is also a slope. If I go on the graph to 22, I'm looking for the slope of this linear piece right here. I can see it's going down by 12 from 15 down to 3, and then it's going across by 4 from 20 to 24. So I would say f prime of 22 is down by 12 and across by 4. Remember that you don't need to simplify any of your answers. It now says indicate units of measure. Well, I need to look back at the graph. This vertical down by 12 was calories per minute. And then the 4 going across this way was measured in minutes. So my correct units would be calories per minute, or you could write that as calories per minute squared. Notice it's the rate of change and the rate at which the person is burning calories on that exercise machine. Let's look at part B and see what it calls for. In part B, it says for the time interval from 0 to 24, at what time t is f increasing at its greatest rate? Well, when they say greatest, I realize that's a maximum problem. And then increasing at its greatest rate, the rate here would be f prime. To find the maximum of f prime, I need to set the derivative of f prime equal to 0. What's the derivative of f prime? F double prime. Okay, let me get that going. I'm looking at this, and I'm looking for my maximum f prime. In other words, I'm looking for my maximum slope. I suspect the maximum slope is going to be over here, and so I'm going to go ahead and start taking a derivative. F prime of t would be negative 3/4 t squared plus 3t, the derivative of 1 is 0, and then I take another derivative. I'm getting negative 3/2 t plus 3. I set that equal to 0 to find the critical point for f prime. And solving for t, I'll have negative 3/2 t equals negative 3/2, so t is equal to 2. I wonder if that'll give me the maximum slope. Let me check that out. Oops, I can see I'm going off the screen a little bit. So f prime at 2 is negative 3/4 times 2 squared, so that'll be negative 3, plus 3 times 2 is 6. I'm getting a slope of 3. The only other place where I see the function increasing is on this interval, and the slope there is up 6 and across 4, so the other candidate, 6/4, that's 3/2. So this is the maximum of f prime. Notice the question says, at what time? So at t equals 2 minutes. Again, I see that I've gone off the screen, so let me fix that. Moving on to the next part of my question. It says, find the total number of calories burned over the time interval from 6 to 18. Well, remember what I have is a rate. To find the total number of calories burned, I'm going to have to integrate my rate of change. So for part C, I'll be doing the integral from 6 to 18 of f of t dt. How can I be sure that this is the right approach? Well, I can check some units. F of t is calories per minute, and I'm multiplying by my differential, which is measured in minutes. These minutes will divide out, and I'm going to get an answer that's in calories. That's great. That's what I'm looking for, the total number of calories. In order to do the integral, I need to think in terms of doing an area from 6 all the way over to 18. How am I going to go about doing that? Well, I would need to take a geometric approach and find the total amount of area between f of t and this horizontal axis on the time interval from 6 to 18. Let me think about the geometry that I know. The total amount of area there, from adding up the rectangle, the trapezoid, and this other rectangle, is 132. So I'm getting 132 calories. And I figured that out geometrically. Let me move on to part D. In part D, the setting on the machine is now changed so that the person burns f of t plus c calories per minute. For this setting, find c so that an average of 15 calories per minute is burned during the time interval from 6 to 18. Okay, they want an average of 15 calories per minute. So I need to use an average value integral. I'm going to add, going from 6 to 18, and then I'm going to divide by 18 minus 6, and I'm going to be doing the integral or the average of f of t plus c, and I need this to be equal to 15. Now that I have it set up, well, in order to solve this thing, I'm going to start by multiplying both sides of my equation by 12. In order to end up with an average of 15 calories per minute, I'm going to have to burn a total of 180 calories. That sounds like a lot of exercise. Then, the next thing I figure is that I need to break this up into two integrals. The integral from 6 to 18 of f of t dt plus the integral from 6 to 18 of c dt is equal to 180. Well, we just found out back in part C that this integral is 132. Plus, if I integrate c with respect to t, I'll have ct. And I can see there's a lot of solving to be done on this. If I subtract my 132 from both sides, I'll have 18c minus 6c equals, subtracting the 132 leaves me with 48, and so 12c equals 48. C must be 4. Oops. Thanks for listening and enjoy calculus.